Our last video, we reviewed limits, which leads directly into derivatives. We're going to start with the limit process of taking a derivative, which is the building blocks of finding the slope of the tangent line and finding the derivative of any function. We'll review all the shortcuts too, but we're going to have at least one problem where you have to do the derivative by the limit process, which is the long way. But like I said, it's where your shortcuts come from. So we're going to start with the limit process where you have the derivative of f of x equals the limit as h approaches 0 of f of x plus h minus f of x all over h. Now I'm using h here. You may have used delta x or some other variable in Cal 1, but h is representing the horizontal distance between 2 points. So as you're approaching 0, it's shrinking that distance between the 2 points. So eventually you get the exact slope of the tangent line at that 1 point. So using the limit process, we're going to take the derivative of x squared plus x plus 1. And I usually always just rewrite the formula. That way I can just substitute directly in and I make less errors by forgetting anything. So rewrite your limit process, and then I'm going to plug directly in there. F of x plus h means anywhere there's an x, I'm going to plug in x plus h. So that's going to give me x plus h squared plus x plus h plus 1. Now I'm putting a bracket around the whole thing just to signify that this whole thing is this part of my equation. And then we've got minus f of x. So just rewrite the whole equation. And then that's all divided by h. So that's my f of x plus h minus f of x on top divided by h. Now that looks very messy, but when you start simplifying, some nice things happen and some things cancel out. So let's go ahead and simplify as much as we can. We're going to take x plus h and FOIL it, so that'll give me x squared plus 2xh plus h squared. And then I've got the plus x plus h. I'm going to go ahead and drop those parentheses just because I don't need them. And then I've got plus 1. And then I'm going to go ahead and distribute the negative into the second bracket. So I have a negative x squared minus x minus 1. And then that's all over h. So if you notice here, I've got an x squared and a negative x squared. That'll cancel. I've also got an x and a negative x and a 1 and a negative 1. So if you notice, everything that didn't have an h term with it will end up canceling out. And that's what it's going to allow me to cancel the h in the denominator and be able to evaluate the limit. So that leaves you with 2xh plus h squared plus h over h. Everything has an 8 in the numerator, an h in the numerator, so I'm going to pull one of those out, which leaves me with 2x plus h plus 1 all over h. And this is where the magic happens. Your h's will cancel. So now I can evaluate by plugging in 0 and not have an undefined answer. So I'm taking the limit as h approaches 0 of 2x plus h plus 1. I'm going to plug in 0 everywhere there's an h. which leaves me with 2x plus 1. Which you know from the shortcuts of taking the derivative is your derivative of this, but that is the limit process to find your answer. Now that's a long way. Like I said, you're going to have at least one question like that on your test, and it'll probably be a quadratic. But after that, you'll be able to use the shortcuts to find derivatives. So let's go through all the derivative rules. The first one is if you're taking the derivative of a constant. The derivative of any constant is just 0. Also, the derivative of x is just 1. Also, remember, if you have a constant times x, since the derivative of x is just 1, that's just going to equal the constant that's out in front of it. Now, the proof of that, you can prove that by the power rule, but you should just know that by our simple derivative rules. Now let's look at the power rule. So if you have a function where x is raised to some power, the power rule says that the derivative of that is n times x to the n minus 1. So you're going to subtract 1 from the exponent, and that's your new exponent. Also, if you have, this goes right along with that, if you have a constant times your x to the n, that is just going to be that constant times the power rule of x to the n. So you're going to have n times x to the n minus 1. So that's your basic power rule. The product rule, if you remember, let's let h of x equal f of x times g of x. So your derivative of h of x is going to be the first function times the derivative of the second plus the second times the derivative of the first. Now, you may have done that in a different order in Cal 1, but the order doesn't really matter because it's addition, just as long as you do the regular function times the derivative of the other plus the opposite. And the answer will be the same. Now, the quotient rule, order does matter because it involves subtraction. So we're going to let h of x equal f of x divided by g of x this time. So if you have a one function divided by another, the derivative of that will be the bottom times the derivative of the top minus the top times the derivative all of the bottom, all over the bottom squared. So this one, order does matter. You have to make sure you start with the function in the denominator and multiply it by the derivative of the function in the numerator, minus, switch it, and then it's all over the denominator squared. Our last rule is the chain rule. And it's just, if you're taking the derivative, remember this notation, d over dx just means I'm taking the derivative of whatever's inside the brackets or parentheses. That just means you work from the outside in and make sure you take the derivative of each step of, or each composite part of your function. So I've got a power, so I need to take care of that. So I'm going to have the derivative will be n times my function raised to the n minus 1. So that's the taking care of the power. But then I also have to take the derivative of the function on the inside. So I take care of the power rule, and then that's multiplied by the derivative of the function. So you have to take the derivative of every single part of it, but you can only do one part at a time, or one rule at a time, basically. So there'll be some examples of those in your practice. If you have any questions, you can ask me about them. We're going to look at a few complicated examples.